chemistry mixtures provide a good opportunity for us to learn how the importance of rational equations need to be solved. In this case, we have Ed, who wants a 50% brine solution for his saltwater fish tank. His tank currently has a 10% brine, and he has on hand an 80% solution to use. What he needs to know is how much of the 80% solution he should add to his 16 ounces of the 10% solution. The first thing we need to do is define our variable x. It sounds like the x is how much of the solution he needs to add. The next handy habit is for us to learn to create a table to organize all of this information that has been written here. This table will typically be in column form, where we're going to consider what original information we have, what added information we have, what is new, and what our ultimate goal is. These are compared by looking at the amounts of solutions relative to the total solution. First, we notice they told us that he wants a 50% brine solution. So we might put this as our ultimate endpoint. We want 50 out of 100 parts to be the brine. Next, it says he currently has 10% brine. It also tells us later that he has 16 ounces. So what that means is, of this total original 16 ounces, 10%, which will convert to a decimal, of the 16 is in fact the brine solution. The following sentence tells us that he has an 80% solution to use. And the question is, our x is how much is he supposed to add? So the total that he's supposed to add is our unknown, and we know that it adds at a rate of 80% of that amount, whatever it is, that he's going to add. Completing the two previous columns then leads us to know what will the new solution look like. Well, it's going to be that 10% of 16 and the 80% of the unknown amount will be the solution amount. The total then is going to be the 16 ounces plus however many ounces. So you notice by adding the original with the amount he intends to add tells us how much new there's going to be. Finally, we recall our goal. That goal tells us that the amount of solution must be in ratio of 50 to 100. This is what allows us to write our equation. Our new amount of solution must be in ratio to our total amount of solution at a rate of 50 out of 100 parts. That is his goal. Having this equation to solve, then, we recall that the product of our extremes must equal the product of our means. Completing this multiplication and writing that product would then result in our need to distribute. Continuing with our algebra to simplify, we end with identifying that x must be 21 1/3 units, in this case ounces, of the solution that must be added, of the 80% solution that must be added to the current in order for him to meet his goal of 50% brine.